Hello, I'd like to do Chapter 7, question number 17. It says, mechanical measurements on supposedly identical objects will usually vary. The variation often follows a normal distribution. So here we have the phrase normal distribution. That's a clue to us that means it's a Chapter 3 question. It's all about normal curves. The stress required to break a type of bolt varies normally with a mean of 75 kilopounds per square inch and a standard deviation of 8.3 kilopounds per square inch. All right, so first of all, even though we're not required to, let's make a quick sketch of this situation here. So here's our normal curve. We have a whole bunch of bolts. The mean of the bolts is 75. That's right there in the middle. All right, standard deviation is 8.3. Now for a quick sketch, let's go ahead and just round that to 8. So standard deviation is approximately 8. So that's 75 plus 8 is 83. Let's just make it quick to add them up here. Plus 8 again is 91. Plus 8, 99. Okay, 75 minus 8 is 67. Minus 8 is 59. Minus 8 is 51. Okay, it's not quite right. 8.3 is a more precise standard deviation, but it's just for a quick sketch. Okay, now part A. It says, what percent of these bolts will withstand a stress of 90 KSI without breaking? So first of all, the variable here, amount of stress required to break a type of bolt. So the more stress it takes to break a bolt, the stronger the bolt is. So these bolts up here in the 90 range, those are the stronger bolts. These bolts down here in the 50s, those are the weaker bolts. Okay, so part A, it says, what percent of these bolts will withstand a stress of 90 KSI without breaking? So in other words, 90 or stronger. So 90 is about here. So this is the region I'm interested in, right there. So what percentage of bolts have a stress uh, a stress point? You could say 90 or above. All right, to do this question, like all the normal curve types of questions, step one is you have to take your number, in this case 90, convert that to a z-score, and then look that number up on the table to get the percentage. And then there's one extra step because it's greater than, I have to subtract from 1. Okay, well, let's get to work. So first of all, our z-score formula here, z equals the particular number we're interested in minus the mean. I'll go ahead and use our normal x bar, although you can use the population mean mu also. That's fine. Divided by standard deviation. I'll just use that for standard deviation, although you could use sigma for standard deviation as well. But it's the structure I'm interested in, not the actual notation. Okay, so that's equal to 90 minus the mean, which is 75, minus standard deviation, 8.3. Now, because I want to get a precise answer, I do want to leave the 0.3 in there. Okay, let's do this calculation. So let's open up the calculator, clear out the old stuff. 90 minus 75 is 15. Divide that by 8.3. About 1.8072. Let's round that to 1.81. Okay, there's our z-score, which means that any bolt that can withstand 90 kilopounds of per square inch of stress is a pretty above average bolt. It's close to 2 standard deviations above the mean. Now, next step, I got our z's. Next step is look that number up on the table. So let's get a table here. So here we have the table A from the back of the book. My z-score, hold on here. Our z-score here is 1.81. Here, let's go to red here. So the first two digits, 1.8, I find those along the left. So 1.8, here we go, 1.8 right there. All right, and then the second digit, the 0.01, You find that along the top. So there's 0.01. So I just go across 1.8, and I just go down until they match up. Right here, 0.9649. So that's the percentage on the normal curve of individuals that would be less than a z-score of 1.81. Now, back to our original here, 0.9649. Let's draw an arrow here, 0.9649. That was a number off the table. Now, that gives us the area to the left. I need the area to the right. So one more step, subtract from 1. It's 1.0000 minus 0.9649. That's going to give us 1.630. So 0.0361 is the answer. So about 3.6% of the bolts will withstand 90 kilopounds per square inch of stress or more. Okay, that is it for part A. We finished part A. Check that off. Okay, now for part B. What range covers the middle 50% of braking strengths for those bolts? So back to our sketch. The middle 50% would be, let's pick another color here. How about blue? The middle 50%, well, we know the middle 68% is 1 standard deviation from the mean, so that would be about 67 to 83. So the middle 50% is probably like 67 point something, maybe 68, to something, maybe 80, 81, 82, something like that. So there's our middle 50% right there. Now, to get a more precise answer, we need to, of course, use z-scores. So middle 50%. Let's talk about this in more detail here. Middle 50% means basically third quartile and the first quartile. The distance between these two quartiles is middle 50%. So I need to figure out what is the z-score of, well, let's go ahead and do the third quartile first. What is the z-score of the third quartile? All right, third quartile means 75%. So that's 0.7500. So I need to go back to our table. Here it is. So this time I'm doing the question in reverse. Basically, I'm asking the question, what z-score would give me 0.7500, which would represent our third quartile. I'll put third quartile in parentheses here. So I need to find the percentage first, 0.75. So where's 0.75? Let's see. Here's 0.77. Here's 0.76. Keep going, keep going. Here's 0.758. Here's 7549, 7517, 7486. Okay, this is as close as I'm going to get to 0.7500. So what is the z-score for that? Well, let's just look across here. That's going to be 0.6, and then look up 7. So 0.67. That's the z-score, which corresponds, at least from this table, as good as I can get. That corresponds with 75%. All right. Now, what z-score gives me 0.250? So let's go to the other table with the negative values. So what z-score gives me, what z-score is going to give me 0.2500? So let's find 0.2500. Here's 0.14, here's 0.22, here's 0.2526, let's see here, 0.2514. Okay, it looks like this is as close as I can get to 0.250 right here, 0.2514. So what's the z-score for that? Well, let's go across. It's negative 0.6 and 7, so negative 0.67. Oh, what an interesting coincidence. For 75%, our z-score was positive 0.67. For 25%, it was negative 0.67. Not surprising, if you look at that normal curve, it's symmetric. So a z0 is in the middle there. 0.67, negative 0.67 gives you 25% that direction and 25% that direction. Okay, so now back to the original problem. So the z-score that for third quartile, we figured that out. It's positive 0.67. And then the z-score for the first quartile, which corresponded with 0.2500, and that is negative 0.67. So now all I have to do is find out, well, what is the breaking strengths, back to our original problem, of our bolts. What's the breaking strength of our bolts that corresponds with those z-scores? So back to our friend, the z-score. Here, let's switch to a different color here. Okay, so our old friend, the z-score formula. Z equals x minus x bar over s. So in this case, we know z. We know mean, we know standard deviation. We just don't know the x right there. So let's start with the third quartile. So 0.67 equals x minus the mean, which was, what was the mean here? 75 divided by 8.3. So let's do this calculation. I multiply 0.67 times 8.3. Do that first. And then that's going to equal x minus 75. Okay, add 75 to the other side. I get 0.67 times 8.3. Oops, hold on here, made a mistake. Plus 75 equals x. Okay, let's do this calculation here. Let's go back to the calculator. 0.67 times 8.3 is 5.561 plus 75, 80.56. Okay, does that number make sense? Let's go back to our original sketch. We knew that the third quartile was here in the low 80s, so 80.56, that makes sense. Okay, then just repeat that same calculation for negative 0.67. So negative 0.67 equals x minus 75 over 8.3. So times 8.3, so negative 7 times 8.3 plus 75. That's going to equal our x again. So back to our calculator. Yeah, this has a minus key right there. So 0.67, turn that, 0.67, turn that negative, times 8.3 is negative 5.561 plus 75, 69.44. Okay, so our answer, the middle 50% of the bolts would have a breaking strength between 69.44 kilopounds per square inch and 80.56 kilopounds per square inch. And that's it.